We're going to take a look at the string handling functions of the standard library. As we know, the C programming language itself does not have any inherent string handling ability, character string handling abilities, so it has to rely on the standard library. There are other languages like Perl, which is made to do string manipulation. And it's a practical extraction and reporting language, so that's what it's supposed to do. But for us in C programming, we're more low-level operating system type programmers and doing that kind of work. So we need other functions to help out that are written in the C language, of course, and they do a lot of the string manipulation for us. When you look through these, as you see this page here, S1 and S2 and N, those are strings. S1 and S2 have to be pointers to sets of strings, arrays of characters with a null at the end of it. Remember, a C string is a bunch of printable characters, and it could be white space, new lines, things like that. But there is always a null byte, a zero value byte at the end of it that marks the end of the string. And the N will be used in these for numeric limitations in case we need to know when to stop, how many numbers of characters to use if we don't want to run all the way to the null. So let's take a look at these. This is string copy. CPY will simply copy beginning at the pointer of S2 into the memory space of S1. If it gets to the null byte of S2, it will stop, and it will place a null byte in the same place of S1. So it's simple copy. String ncopy, the next one, copies S2 to S1. If there are many more bytes here, this N will stop it. So it will not continue to copy from string 2 to string 1. It will only take n number of bytes. String cat is concatenation. S2 will be tacked to the end of S1. S1 had to be long enough total to receive and contain both S1 and S2, string 1 and string 2. So string 1 has to be much larger and have a null byte someplace in the middle of the cleared buffer before you go tacking string 2 onto the end of it. String ncat, same thing, S2 tacked to the end of S1 with a limiter numeric value. String compare, comparing S1 and S2. If S1, string 1, this is an alphabetic compare, is less than, alphabetically, than string 2, the return of string compare will be less than 0. If string 1 is identical to string 2, same length, same characters in every byte, upper and lower case, it will return 0. String comp will return a greater than 0 value if string 1 is larger than string 2. You can probably see what it's doing. It's subtracting each character one by one of string 2 from string 1. So in here, we would be subtracting this string from this S from this S, and we get a 0. T from T is 0, R from R is 0, C from N, we have a larger number, and all of a sudden we have a difference. That is where string compare would stop right now. C is different and smaller than N. We have a larger number because N is numerically greater than C in ASCII, and this case would occur. We would return actually the difference between N and C. All right, see what's happening there in string compare? String ncompare compares these two strings and only goes so many characters into it, delimited by it. The number here, this is just an integer. Here we're looking for this character. C is a single character, not a string. We are looking for that character someplace within S1, in the length of whatever is there in S1. And we will return a pointer within S1 to that location. So we can look for a letter someplace inside an entire string. String R, CHR, starts at the end of S1 and works its way backward, looking for the character. So we would start here, let's say, if this was our string, and we would look backwards trying to find a letter. And then if we found it, we would return the address. Some more string handling. Here we have strspn. What we are looking for is these characters. S2 is a string, but it is a string of characters. It can have A, B, C, D, or some other sequence in it of different characters. And what we're doing is we're finding out how much of S1 is made up of S2. So if we did, let's say this is the string, how much of S1 is made up of S2, and S2 was the letters HOW, we would see that 3 would be returned because the H, O, and W is where the prefix stops. That's how much of the beginning of S1 is in S2. If you make S2, let's say, just a space, you can find out how many leading spaces might be in this string 1 if you need to trim off some text or something. So that's what's going to happen. The characters, not in any particular order, if we had an H in S2, we would return 1 because we would say that the prefix here that's made up of H's is just one character. We're looking for these repeating characters in the front end of this S1 in string span. String C-span, CSPN, is looking for how much of S1 is not in S2. We want to know how far we get down S1 before we hit one of the characters in S2. Okay, so how much of it is not in S2? Here is a string PBRK. And what we're looking for here is we are looking for the entirety of string 2 any place in S1. Where is any of S2 in S1? So we're looking to see if it's any characters of this are located in there. String, we're looking for the entire string of S2. Not just any sequence of characters, but the entire string someplace in S1. So if this is the string that is in S1, this little comment here, and the word entire was in S2, we would find out that it would be 0, 1, 2, 3, 4, 5, 6, 7, and 8. The beginning address plus 8 is what would be returned. So this pointer plus 8 would come back as the where, and we would find that the entire word that is in S2 would be contained in S1, string. String length of S1, simply that, how long is S1? Error message. If we pass string error and we pass an error number, say from a file function that we did earlier, a string error will give us back into a string buffer the error message that it would print out. And we already saw how to use p-error to print an error. Well, p-error is calling string error to get the error out of the operating system and put it into error message, and then we can do something with it.